Hello and welcome back to 19.2 surface area of prisms and cylinders. This is going to be on page 21. If at any point I'm going too fast, please feel free to pause at any moment. So the first question it's going to ask is to explain in your own words what is surface area and what does it mean to find it. So as you can see here from our example on screen, it says what is surface area? Well, it's essentially a 3D shape that we kind of unwrap, if you will. Essentially, we find the area of each one of the faces, essentially the front face, the back face, the left, the right, and the top and bottom. So here this is kind of an unraveled net of a 3D shape. So we found the area for each one of these faces to be 4, because that's 2 times 2. We knew to use 2 and 2 because those were the dimensions of our cube, or 3D shape. And then all we're doing is adding up all those areas. So go ahead right now and in your own words write down what you think surface area is. And unpause, we're going to continue on. Well, it says what does the lateral area of a 3D shape mean? So as you can see from this, we have a left face of our shape, we have a right face of our shape, a front face. See, you can even draw faces on it if you'd like. I know this is not in your packet, I'm just showing this on screen, but if you want to draw this out, it's pretty fun. But essentially there's a front face and a back face to our shape. So lateral, there it is highlighted, just means it represents essentially the faces of our 3D shape. Notice there is a top and bottom that I did not highlight in green. Alright. So, under explain 1, it says finding the surface area of a prism. So here, this will be our lateral area, which is just base perimeter times height, plus 2 bases, because there is a top and bottom portion for every 3D shape that we see in this particular lesson. All right, so let's see here. We want to gift wrap a right prism. Find the total paper that would be needed, if we didn't have any overlap, of course. So, first we want to locate what our 3D shape is. In this case, usually it's the bottom portion. It would be this little rectangular shape. So it says calculate the base perimeter. So notice our base perimeter is essentially when we add the lengths of our sides. So take a moment right now and add up all those lengths together. And that would be 46. The height of our rectangular prism is 5 inches. And then the area of our base. So again, it's that same rectangular shape, but we're going to be multiplying those two together. And notice on screen, I do have a perimeter for our rectangle, perimeter for our triangle, perimeter for our circle. I'm going to put those in quotes because that really is circumference. Area of our rectangle, area of our triangle, area of our circle. And I'll draw a little picture. If you'd like, you can take these down as notes. You don't have to, but students in class found it quite helpful, actually. I know that's a horrible triangle, but let's just pretend it's a great triangle that I have drawn there. So the area of our rectangle would be essentially those two numbers multiplied together. So take a moment and do that now. And hopefully you got 90. So to find our surface area, we're going to multiply these two parentheses together and multiply that 2 and that 90 together. Take a moment and do that now. That would be 230 and 180. And if we add that up, what would that be? 410. All right. So here is a different prism. Notice that our base is slightly different. That's a triangle! So we're going to find the perimeter of our triangle. Unfortunately, though, you'll see one side has 3.6, the other side has 6 inches, and then this other side is left blank. So we do have to find that third side. So I'll draw this out. And you're wondering, how am I supposed to figure out that third side or shape? Well, third side of that shape? Yeah, third side of that shape. Well, we're going to use something called Pythagorean theorem. I know you're like, what is that? Well, it's essentially where we use with only right triangles. So let me go ahead and just make sure that that's apparent. That is a 90-degree or right triangle. Notice that this side is the side opposite our 90-degree, otherwise known as our hypotenuse. And these other two sides will be called our legs of our triangle. Now I know this is blank and we don't usually leave stuff blank in math. So I'm going to use X for something we don't know, which is that third side we're trying to find. So let's go ahead and plug some stuff into our Pythagorean theorem. So feel free to do that now. Hopefully you wrote this in. And take a moment and figure out what 3.6 squared is and what 6 squared is. Hopefully you got 12.96, 36. What's the opposite of adding? Subtracting. So let's subtract for both sides. And that would cancel out. And I'm left with x squared equals 23 and some change. Let's go ahead and square root both sides. And hopefully you got x equals 4.8. You're like, why did I have to figure this out again? Because we need to find the perimeter of this triangle. We can only do that if we can add up all those sides. So now that we know them, let's calculate our base perimeter. Let's go ahead and add up all three sides. 3.6, 6, 4.8. What would that be? 14.8. The height would be about 8.5. So put that there. And then our area of our base. So again, we're going to calculate the base area. So here we have this triangle. And we're going to essentially take our legs of our triangle. And we're going to use this area of our triangle formula. So 3.6 times 0.5 times 4.8. What would that be? About 8.64. Take a moment right now. Go ahead and work that out. And unpause. Hopefully you did that because I want to make sure that you're actually working on this work right along with me. That would be 122.4, 17.28. And if we added that together, did you do that? Did you add it together? It'd be about 139.68. All right. Moving right along, we've got one more formula to learn about, and that is the surface area of our cylinder. So here it's in your packet. Notice how this one will also have two bases, a top and a bottom. In this case, it will be circular. And the lateral area will be 2 times radius times height. So take a moment, copy that down. That's going to be there for your reference as we approach. Oh, they want to know what the difference and similarities are for finding the surface area of a prism. So what is a similarity that you notice? So here's a picture of what you notice, and try and find a difference that you notice. I will write the formula so you can kind of look at that as well. So surface area of this would be lateral plus 2 base. In fact, this one will also have a very similar formula. Though notice our base is quite different, whereas our base for this one will be pi r squared, and our lateral area will be 2 pi r times h, r being radius and height. So that's kind of a difference I notice also, is that, you know, there's circular bases. We're using pi, whereas in this one, we're not. Though the equations are very similar, though. All right, moving on. So let's go ahead and work this out. So if we have our shape here, let's identify the height of our 3D shape. In this case, from the top to the bottom, which is 15. Our radius, oh, they give that to us. That's 6. Let's go ahead and plug that in, and let's take let's calculate. Let's take a moment to calculate the terms of in pi. By the way, in case you were wondering, what is that weird symbol she keeps using? It's pi, not the kind you eat, but the mathematical symbol for, and an approximation would be about 3.14, though you know it goes on forever. If you plug that in your calculator, if you ask, Google, what is pi? It's a really long number. It actually doesn't end at all. So that's why we use this symbol. So hopefully you calculated that. That would be 180, and that would be about 72. So let's add up 180 plus 72. About 252 pi. Now notice how it says round to the nearest tenth, so we're going to take a moment and let's go ahead and use that approximation for pi 3.14 times, Mrs. A, you need to fix that, which I will do now. Now that we fixed that to be 252 times 3.14, that would be about 791.28. And yes, you can go ahead and round that. All right, let's take a moment now to identify our height. In this case, oh, that's 80. So even though it's sideways, that's still our height. Identify our radius. In this case, what's half of 72? Now we're halving this because essentially that's the measurement of from one end of the circle to the other, and radius is half. So what is half of 72? 36. So let's plug those in. Let's take a moment and calculate this out again, just in case you forgot pi. That's what that symbol's called, and the approximation for that would be 3.14. All right, so let's take a moment and work that out. That'd be about 5,760, 2,592. Let's go ahead and calculate that out. And that would be about, 8,352. Let's take a moment and calculate it out to be in decimal form. Pause and do that now. And unpause. Wow, that number's huge. Awesome. All right, before we go on to explain 3, we'll see you back here for the next video. This will be a part 2 for this lesson.